Hi, this is Bala, and I'm exploring the LeetCode. I'll start with the first uh, number one.py. This is the first LeetCode program, number one. Uh, Given an array of integers, nums, and an integer target, you need to find out the indices of that numbers whose sums could make that target 9. In this array, number 2 and number 7, when you add it, you get the 9. So the output should be that 0 and 1, first and second indices. Okay. Likewise, 3, 2, 4, and the target is sum has to be 6. So 2 and 4 is 6. Number 1 and 2. Sorry, indices 1 and 2. Likewise here. So what I'm going to do, I'm going to give these 1.py is the first lead code problem. And it is two sums. And oh, okay. Yeah, so I have given to Gemini, and it is saying that thank you for letting me know. I'll remember that. Is a two sums problem. Is there anything I can help you with regarding this file or any other file? Okay. So I need a help. Don't give me the S1 solution code. Help me to understand the problem. Okay, let's see what it has given. I can help you to understand the two sums problem. The problem asks you to find two numbers in a given array of integers that add up to a specific target integer. You need to return the indices of these two numbers. Here is the breakdown of the key points. Input, an array of integers and a target integer. Output, a list of two integers, which are the indices of the two numbers in nums that sum up to the target. Okay. Constraints, there will always be exactly one solution. Okay. And there will not be duplicate. And you cannot use the same element twice. Understand? The order of the returned indices doesn't matter. Okay, so it could be 0, comma 1 or 1, comma 0. Let's look at these examples provided in the file to solidify our understanding. Okay, numbers. Okay, that is okay. The problem also includes a follow-up question asking for algorithm with the time complexity less than big O n squared. Okay. So number of array is 4 and should be less than, should not be like a n squared. This hints that a brute force approach, checking every possible pair of numbers, might not be the most efficient solution. Does this explanation helps you understand the problem better? Let me know if you have any specific questions. Okay, now let's see. Okay, forget about for now. Let's ignore the time complexity. Let's start with brute force implementation. Could you again, could you give me the code for brute force? Okay. Okay. And so you want to start with a brute force approach to solve the two-sum problem, and I can help you with that. Or putting the complete code solution directly would defeat the purpose of. Okay, that makes sense. You practicing and learning instead I can guide you through the process of implementing the brute force solution by breaking it down into smaller steps and explaining the logic behind each step. Okay, here is how we can approach the brute force implementation. Iterate through the array. You'll need a way to go through each number in the nums array. A loop would be suitable for this. For each number, check the rest of the array for every number you are currently looking at. You need to check if any other number in the array, when added to the current number, equals the target. That will require nested loop. Avoid using the same element twice. Make sure the nested loop doesn't check the same element against itself or use the same element from a previous iteration. Check if the sum equals return the indices. This is okay. Think about how you would write the loops to achieve this. How would you access the numbers and their indices? And how would you ensure you don't use the same element twice? Once you have a basic structure for the loops, you can start adding the logic to check the sum. If you get stuck or if you want to go pro, feel free to ask. Okay. Okay, let's give a try. Okay, so here I have the basic structure, the template. I want to have the result and okay. So first I need to iterate through the. I have created the test cases, basically what they have given. These are the test cases, but let me start with that for loop. Okay, why don't I use for I come on now in yeah, that is what enumerate. Enumerate nums. Okay. And It's giving me. Okay. For j comma num2. Okay. In that case, I'll put I comma num1. And for j num2 in enumerate nums2, I and j not equal, I is not equal to j and num1 plus num2 equal to target. Then result is I1, I comma j. Okay, that is works. Okay, let me try that first here. So initially I tried all is giving result as none, and that is what the right one. Okay, now this time I'm getting the result. Okay, and that seems to be the right one. The order doesn't matter. 1 comma 0 doesn't matter. Yeah, so that is okay. Okay, so it is a outer loop, and for j num2. Okay, so the if. Okay, so this is n squared. So we are iterating 2 times, and num1 plus num2 equal to target. Okay. Okay, so we have implemented the brute force. Now let's explore the optimized implementation. Okay. Okay, great. You have successfully implemented the brute force solution for the two-sum problem. Now let's explore how to optimize it to achieve a time complexity better than O n squared, big O n squared. As we discussed earlier, the brute force approach involves checking every possible pair of numbers, which leads to a quadratic time complexity. To optimize, we need to find a way to avoid this nested iteration. Think about what information you need when you are iterating through the array. For each number num, you want to find if there is another number complement in the array such that num plus complement equal to target. This means complement equal to target minus num. So as you iterate through the array for each num, you need to efficiently check if the required complement exists in the remaining part of the array. How can you quickly look up if a specific value exists in a collection of number? What data structures designed in efficient lookup? Consider these questions. What do you use it? Okay. Okay. Once you have an idea, the data structure, you would populate it. How do you use? Okay. Is that the right way? Let's see. Okay. Uh, or okay. So the complement is equal to target minus num. 1. Okay. For j num2 enumerate, if num2 is equal to complement and I and j is not equal, the result is 1. Okay, let's see. Okay, that is also working, but what is it what? Oh, okay. Could you take a look at our implementation and suggest if there is any other way. Okay, I see you have. Okay, let's see. I see you have implemented the brute force approach using nested loops. This is the correct way to solve the problem, and it clearly demonstrates the logic of checking every possible pair. The approach has a time complexity. Okay. For each element in the array, you iterate through the rest. To optimize it, we can use a different approach that reduces the time. As we hinted before, can help us achieve this. Oh, okay. One common and efficient way to solve the two-sum problem with a better time complexity is using a hash map or a dictionary in Python. Dictionary. How can you use a dictionary to optimize the solution? Initialize an empty hash map. Will store numbers you have encountered so far along with the indices. Iterate through the array. Go through each number in the nums array. For each number, calculate the complement. Calculate the complement needed to reach the target. Check if the complement is in the hash map. Look up the complement in the hash map. If the complement is found in the hash map, means that you have found the two numbers that sum up to the target. The current number index and the index stored in the hash map for the complement or your result. The complement is not found in and the current number and it is indexed. Okay. Wait until the solution is found. Okay, that is good. Let's see that. Mm, look up. Yeah, that is a dictionary. Okay. So, I think what we need to do, we have to remove this second loop and yeah, you store that number in the dictionary first. Oh, okay. So the dictionary is created. Now you have this one. Okay. If complement in lookup dot keys and the lookup is not equal to I, result is okay. That is a good one. Okay, if complement in lookup dot keys and lookup complement is not equal to I, the result is I comma lookup complement. Yeah, that is good. Now here, oh, okay, so you're first building the first iteration is all about first iteration is build is to build the lookup. Okay. So what will happen if there is a duplicate? Num1. Yeah, that is a problem. Okay, let's see. Wow. Huh. That's a good comment. Okay. Is to find the complement from the lookup. Yeah. Lookup. Yeah. Okay. I have only concern is for the duplicate. Well, let's see. Okay. In lookup dot keys and lookup complement is not equal to I. Oh, I think okay. That will take care of the duplicates. Okay. Let me ask, okay. Oh, how does it handle? How does it handle duplicate keys? Okay. An excellent question and a crucial point to consider when using a hash map for this problem. And using a hash map to store numbers and their indices to some, you need to be careful. Duplicate numbers in there. The goal is to find two different elements that sum up to the target. If there are duplicate numbers in the input array and the target requires using one of these duplicate numbers, you need to ensure that you don't use the same instances of the number twice. You need to use two different instances at different indices. Okay, target 6. You simply store each number and its first encounter. Okay, if you then check hash map 3, you get 0, comma 0, okay? Which is wrong because you used the same element twice. To currently handle duplicates, when you check the complement in the hash map, you also need to make sure that the index stored in the complement is not the same. Yeah, that is what this code does it. Okay, processing. It is how you can modify the logic to handle in the hash map. Current index. So yeah. When adding number and its index to the hash map, store the current number as a key and quickly look up you have encountered. Let's check out. Okay. Yeah. Okay. This all looks good, but what is happening if we give an array, empty array and then empty array? Okay. Let's add one more test case. We give an empty array and then expecting a target. Oh, yeah. Okay. The result is none. Okay, that is good. And if we have a 6, 6. Oh, two sums. Okay. Result is none. Oh, okay. Okay. And then what else I want to have it? Yeah, this covers even the duplicate also. So I want to have one more use case where the 1, 2, 7, 11, 15. I just want to make sure that sum is not there. That is also none. Okay, we got it. Let me stop sharing and